plus 1. All right, so if that is the case, this integral is going to be over two different elements over which this integrand is non-zero, right? Okay, so it's going to be equal to integration from xi minus 1 to xi, and between x minus 1 xi minus 1 and xi, what is the value of d phi dx? Right, just to look at this function, it goes from 0 to 1 over a region of this width linearly. What is the derivative?
1 over xi minus 1.
Yes, 1 over the size of this element, right? And I need to square it dx. So that's over this, the first element, and I also need to plus what is the derivative on the second element.
1 over xi plus 1 minus xi.
And negative, right?
Yes.
Okay, but because I'm squared, I don't care about the negative in this case, so I just write it as what you said. Right, so this is the diagonal. So we know, we figured out, okay, now all the diagonals. I mean, in this case, the diagonals can be different. If I have non-uniform spacing, then for every I, the diagonal might be different. So now the third and only remaining case is I, well, without loss of generality, I'm just saying I equal to j plus 1. If j is equal to I plus 1, you just switch the indices, right? You still get the same thing. So let me just say I equal to j plus 1. So ai of I and I minus 1 is equal to what? Now this is the case where I have to have an I and I have a green one that is like that. Okay, so its non-zero region is this. And I'm going to be integrating the derivative of phi with the derivative of the green phi minus 1. So in which region should I be integrating this? In which region is the product of the derivatives non-zero? Okay, I have a red function multiplied with the green function. Yeah, the overlapping region, exactly. I didn't draw it, but the red function is actually 0 over here, and the green function is 0 all over here, right? So basically, only the overlapping region from xi minus 1 to xi, I would have a non-zero product. So what is the product, though? What is the product of the two derivatives? What is the product of the derivative of the red slope with the green slope? Oh, it's something very similar to this, right? But have the opposite sign because it's a positive slope multiplied with a negative slope. And the magnitude of both slopes are the same because actually they vary, one from 0 to 1, the other from 1 to 0 within the same delta x. So the product is going to be negative of the square of xi minus 1. Okay, so now we have figured out also the off-diagonal components of the matrix. Now we have the entire matrix, right? So let's actually use this knowledge to actually start to solve an equation. I mean, before we actually, we still have to figure out the right-hand side, right? But let's just use a easy function. Let's say f equal to 1. Okay, so let's actually try to figure out the right-hand side first for f equal to 1. So if f equal to 1, then the bi is equal to integral from 0 to 1 my phi times 1 dx. And again, if you look into the form of phi, right, I have xi minus 1, xi plus 1. What is the integral of this phi over the entire domain? Yeah. That's the right-hand side, right, for this very simplest case. I mean, I'm basically solving the equation second derivative plus 1 equal to 0. We know the answer is a quadratic, right? We can try to see how well we are solving this equation. So in this case, what is my bi? What is the area of the triangle? Integral, right? Half of base times height, and the height is 1, so it's half of the base, which is xi minus 1 minus xi minus